So this is our first equation. This defines, by the way, a magnetic field. Okay, so if we have a current carrying wire, okay, in a magnetic field, okay, there will be a force equal to I times the length of the wire, right, times the magnetic field times the sine of the angle between the current and the magnetic field. Okay, that's our formula here. Okay, now notice that doesn't just mean times. That's actually a vector cross product. Okay, the magnitude of that vector cross product is ILB sine theta. Okay, but it has to go in a crazy direction. I've got other videos that show you how to do this right-hand direction. Okay, but it goes in the right-hand direction. I'll talk through it here, but you really can't see it in blue pen land. So we'll have to defer to the other videos to figure that out. Okay. But basically, a vector cross product is in the direction perpendicular to the plane that the current and the magnetic field lie in. Okay, and it's the sense that one thing is perpendicular to another. Okay, so you get a maximum force when that angle is, of course, 90 degrees, because the sine of 90 is 1. Okay. So F is our force on the wire, I is our current in amperes, right? L is the length of the wire that intersects the magnetic field, right? And then literally, B is defined in terms of this formula here, right? 1 Tesla is a Newton exerted on 1 amp with 1 meter of overlap of the wire and the magnetic field. If it exerts 1 Newton, then it's 1 Tesla, right? Okay, which is huge. That's a huge magnetic field. I'm just going to say. Gauss, Tesla's 10,000 Gauss, which is another unit of magnetic field strength. And then theta is the angle between B and L, okay, the wire, okay. You can also, the wire and the current, right? So for example, if I've got a magnetic field that's to the right, okay, and then let's imagine that I've got a current that's flowing like this. That's my current, okay? What you want to do, if this is my magnetic field, okay, you want to use this angle. Now be careful, because they can give you problems where the angle that they give you isn't the right angle. So draw a picture of whatever they talk about, and I'll show you an example of this, right? And figure out for yourself what is the angle between the current and the magnetic field, right? Place some tail to tail, right? And then find that angle there, okay? And what else should we talk about? Anyway, I do a demo at this point. I've got these giant magnets, and at this point, we notice that the magnetic field is, of course, north to south, right? So the magnetic field is this way. It's perpendicular to that current, right? And then we put our index finger this way, right? We put our middle finger down, right? Index finger that way, middle finger down, and my thumb points out, and this wire magically, when I turn it on, comes spitting out of the jaws of that magnet. It comes out, it comes towards you, right? Okay. And then just one final thing about magnetism too is that we've got directions. Obviously, we can go up the page and to the right, et cetera, right? We've also got dot is equal to out of the page. Okay, and X is into the page. How do you remember that? Well, just think about an arrow. Whoops. Okay, an arrow's got a point on the tip of it, right? The point, if the arrow's coming at you, you see the point of the arrow, right? And then on the back, of course, it's got feathers, right? Now, never mind that nobody fletches an arrow with 4 feathers. Try it sometime. It's an interesting experiment. Okay, never mind that, okay? Let's just imagine that you did quad fletch an arrow, right? That you're seeing the tail feathers of the arrow, okay? All right. So this is our right-hand rule, and what you do is you'll have to look at the videos for this, right? But your index finger goes in the direction of the current. The middle finger is B, right? And this is, by the way, if it's just quantity X cross Y. I always choose something wrong, right? This is the first quantity, that's the second quantity, right? So this is always index, this is always middle finger, and then your thumb is the direction of the resultant of the cross product, okay? And then we go through this. We'll do this in class. I've got other videos where I do this, where I use the camera to do this. So you'll have to look at those to learn this right-hand rule. Okay. All right.